Okay, Assalamualaikum warahmatullahi wabarakatuh dan salam sejahtera. Okay, so here we continue with coefficient of determination. Okay, before this we discuss about correlation coefficient. So for coefficient of determination is simply R squared. Okay, we squared the value of the correlation coefficient, then we'll get coefficient of determination. So it is also known as the proportion of variance and interpreted as the proportion of variance in the dependent variable, yeah, that is predictable from the independent variable. Okay, so we're talking about variation in dependent variable, which can be explained by the independent variable. Okay, so normally to interpret the value of the coefficient of the determination, we use in terms of percentage, yeah. Or in other words, is the percentage of the variation in the dependent variable that can be explained by the independent variable. And the value of R squared is between 0 and 1. Okay. Before this, R is between -1 and 1. So for R squared, it is between 0 and 1. Okay. Okay, next, how do we interpret? Okay, for example, if R squared is equal to 0, that means the dependent variable cannot be predicted from the independent variable. So if it is equal to 1, yeah, if it is equal to 1, then the dependent variable can be predicted without error, yeah, from the independent variable. So normally, this is very ideal case, but normally the value of R squared is between 0 and 1, either close to 0 or close to 1. So it indicates the extent to which the dependent variable is predicted from the independent variables. Yeah, so that is how we interpret. Okay, we look at some example here. So for example, if you have R squared equal to 0.1, yeah, so you can interpret as, yeah, change into percentage. 10% of the variation in Y can be explained by X. Or you can relate to the, or you can say that 10% of the variation in Y is predictable from X. Okay, another example. If R squared equal to 0.8, that means 80% of the variation in Y can be explained by X, or 80% of the variation in Y is predictable from X. That means X has a very strong effect on the value of Y. Okay, because 80%, yeah, can be predicted by the independent variables. Okay. In the first example, 10%, so X effect is very poor, yeah, because it's only 10%, yeah, as compared to 80%. Okay. Okay, using the same example as what we have discussed in example 5.2. Okay, in 5.2, we have the correlation is 0.94482. Okay, to find the coefficient of determination, we square it, yeah, just square it, and then we get 0.8926. So how do we interpret this value? Okay, so that means you change this into percentage. 89.226% of the variation in the final marks, yeah, can be explained by the number of hours students spend to study. Yeah, the effect on the number of hours students spend to study, yeah, which is 89.26% of variation in the final marks. Yeah. And you can add further if you like. Yeah, the balance of it, which is 10.74% of the variation in Y, is due to other factors. Yeah, so you can add if you like. Yeah, this part. If not, you can just leave it. Yeah, what is important is the major percentage. Yeah. Okay, now let's look at exercise 5.1. Okay. Okay, this is a real data, and we would like to find the relationship between carry marks and final exam. Okay, I have 10 samples, yeah, 10 students, yeah, from Faculty of Engineering Technology. So this is their carry marks and also their final exam. Okay, normally in the question, it doesn't specify which one is independent, which one is dependent variable. But you need to think a little bit, yeah. In this case, we know that final exam is the resultant of the carry marks, yeah, they got. So the final exam score. So if they have, normally if students have a good carry mark, that means they perform in all of the assessment, okay, when they do final exam, they will perform better. Yeah. So okay, final exam in this case is 40%. Yeah, and the carry marks is 60%. Okay. Okay, the first question, identify the independent and dependent variable. So independent will be carry marks, yeah, which is X, yeah, in this case. And the dependent variable will be the final exam score. Okay, so this is Y. Okay. Okay, next, we would like to draw scatter diagram. Okay. So scatter diagram is simply you draw a graph, a plot between X and Y. So X will be the carry marks, yeah, and Y will be the final exam score. Okay, then you can draw. So if you draw using using Excel, you will get something like this. Okay, this is just roughly. Okay. So how do we interpret this one? Yeah, normally in the question, we ask you to interpret. Yeah, what do you observe from the plot? So we observe that a positive trend. Okay, positive trend. That means has the carry marks, yeah, increase. Yeah, so has the final exam score. Okay, so that is what we can see, yeah, from the graph. Yeah, before we do any mathematics on that. Yeah, so there is a positive trend. So we can see that X increase, Y also increase. Yeah, positive trend. So has the carry mark increased, so has the final exam score. Yeah, carry mark increase, so has the final exam score. Okay. In C, you need to find the summation. Okay, like I mentioned previously. Okay, you need to know how to use your calculator. Okay, so I'll give you this number. Later on, you can check. Sum of X is 401. Yeah. Sum of Y is 259. Okay. Sum of Y squared is equal to 7329. And sum of X squared is equal to 16837, and sum of xy 10913. Okay, so you can key in the data in your calculator and you can automatically get all of this value. Okay, and then from there you can determine the value of sxx. So you should get equal to 756.9. Okay, SYY equal to 620.9, and SXY equal to 527.1. Okay, and from there you can determine your R, which is equal to 0.7689. Okay, and then you need to interpret this. That means, so R here is more than 0.7. Yeah, so it says that there is a strong, yeah, there is a strong positive, yeah, linear relationship, yeah, between carry marks and final exam, yeah, score or final exam mark. Okay, so that is how you interpret. Okay, so C. Okay, this is D. Yeah, this is D. Okay, E. You need to find the coefficient of determination. Yeah, so that means R squared. So you squared 0.7689 squared. So this will give you 0.5912. So how do we interpret it? We say that 59.12% of the variation in final exam score, okay, can be predicted by the carry marks. Okay, so that is how you interpret it. Okay. So F, what does it? F, dia kata give your general comment of the student's performance. So this is open question, yeah, very subjective. So you can say that some students have good carry marks but did not perform in final exam. Yeah, so maybe you can identify a particular student, student number 1 and number 9. Yeah, so maybe you can comment. This is just a general comment. So some students, yeah, scored well in carry marks, yeah, in carry marks, but not doing well in final exam. Yeah, example, student number 1 and number 9. Yeah, so when number 1, it only scored number 1 40%. Yeah, number 1, for example, 40%, x equal to 40, y equal to 24. Yeah, maybe due to some problems during the final exam. And student number 9 also, yeah, the carry mark is very good, 49/60, whereas in the final only scored 29. Yeah, so this is a particular example. Okay, then you can give any comments, yeah, that you observe from the data. Okay, so that's all for now.